All right, let's dive into two of the trickiest concepts in Python that trip up almost every new programmer: how data gets passed into functions and how to stop your code from blowing up when things go wrong. Get these right, and you're well on your way to writing much more solid code.
You've probably asked this yourself, or at least seen some pretty heated debates about it online. Is Python pass by value or pass by reference? It's the classic question. But what if I told you that, well, it's the completely wrong question to be asking in the first place?
And in fact, as one instructor pointed out, a lot of the articles out there that are titled pass by value versus pass by reference they completely miss the real point about how Python actually works under the hood.
Okay, so if that's the wrong question, what's the right one? Well, the real answer isn't about how things are passed, but it's all about what is being passed. It sounds like a tiny difference, but trust me, it's a huge one.
And this is where we get to the heart of it. Python uses a system that people like to call pass by assignment or pass by object reference. All that really means is that a function always gets a pointer, a reference to the original object. But here's the twist. What happens next depends entirely on whether that object can actually be changed.
And that right there is the core concept you have to get your head around to understand any of this: the difference between mutable and immutable objects.
So this is it. This is the whole story right here. You've got your immutable types, things like numbers and strings. Once you make them, they're set in stone. You can't change them. And then you've got the mutable types, lists, dictionaries. These guys are designed to be changed, and that single difference changes everything.
Okay, let's make this real. Look at this example with an immutable type, a number. We pass a number into a function, we try to change it inside that function, but when we print the original number, it's exactly the same. Why? It's because you can't actually change the number 5 itself. What Python does instead is just create a brand new number. Your original variable, it never stopped pointing to that original 5.
But when it comes to mutable objects, it is a completely different ballgame. And I love this analogy. Think of it like giving your object a temporary nickname.
All right, so let's start with a simple list. We all know lists are mutable, right? So here's what's really going on behind the scenes when we pass this list to a function. This nickname system is the key to understanding everything. First, and this is super important, the function does not get a copy of the list. It gets a direct pointer right back to the original object in memory. Then, inside the function, that same object gets a new temporary name, our nickname. So you have one object, but two names pointing to it.
And that's why this happens. When we use the nickname to mess with the list, say we append a new number, that change is permanent. It affects the original my list because, well, there's only one list. It doesn't matter which name you use to change it, you're changing the one and only object.
Okay, so we've got a handle on mutability. Getting that wrong can cause some really sneaky bugs. But what about the stuff that just breaks? Things that are totally out of your control. I'm talking about runtime errors, the kind that can bring your whole application crashing down. And these are just a few of the common landmines waiting for you out there. Trying to divide by 0, or accessing an item in a list that isn't there, or looking for a dictionary key that doesn't exist. These things often happen because of weird user input, and any one of them can stop your program dead in its tracks.
So what's the solution? How do you stop your app from just blowing up? You can't just cross your fingers and hope for the best. You have to actually plan for things to go wrong. You need to build a safety net.
And thankfully, Python gives us this really elegant tool called the try except block. It's so simple. You put the code that might break, the risky stuff, inside the try block, and then you put your backup plan, what to do when that error happens, inside the except block. That's it. It's your built-in safety net.
But why is this so critical? I mean, really? Well, check out this number. Our source gave this incredible example of a bank. If their online banking app goes down for just one day, one single day, it could cost them more than $500,000. Ouch.
And that's the bottom line, right? In the real world, professional software can't just crash. It has to handle problems gracefully and just keep on running 24/7. Error handling isn't some nice-to-have feature. It is absolutely essential. So I want to leave you with this question. The next time you're writing some code, just stop for a second and ask yourself, what are all the hidden things that could go wrong here? What happens when the unexpected happens? And have I built the safety net to catch it?